And there's no other kind-hearted souls in the class. No, they just weren't thinking. I know there are kind-hearted souls in here. There's lots of them, actually, which is nice. All right, so arithmetic sequence, common difference. And so example A, common difference is 4. Finite sequence, right, because it ends, doesn't go on forever. Goes on forever, infinite. It ends, it is finite. All right. So, example B. So obviously, the common difference is, what is it? What is it? Negative 2. Wait, it's 2. It's 2. Negative 5 plus 2, negative 3. Negative 3 plus 2, negative 1. Negative 1 plus 2, 3, right? Etc., etc., etc. Did I get anybody to change when I did that? Did anybody change? I'm just curious. See, there are times you got to stick to your guns. There are other times where you got to think about what's being said and convert, but there are times when you got to stick to your guns. So that was one of those times. All right. Is it infinite or finite? It is infinite, of course, because it goes on forever and ever and ever. Amen. All right. C. All right. Figured that one out. No problema. You can do it. Ethan says it is. And how many concur? All right. How many know what concur means? Yes, it means you agree. Concurrent lines intersect at a point means if they intersect, they have a common. If you concur, you're in common with them. Concurrence. All right, so D equals negative 4.2, and that is, again, an infinite sequence, right? Again, don't forget the first term is the negative 3.5, the second, negative 7.7, the third, negative 11.9. If this were sequence A, what would be A sub 4? What would be A lowercase sub 4? Raquel? $11? Base 10 system. It would be Nick. Help her out. Negative 16.1, right, would be the fourth term. Remember, the lowercase letter tells you you're looking for one of the terms. The subscript tells you what number term, the fourth term, and the fourth term is negative 16.1. Number 2. Number 2. All right, so you have two different kinds of formulas. Let's first talk about the recursive formula. The recursive formula. And what this formula does is it describes the sequence in respect to the previous term. Describes the sequence in respect to the previous term. Now, how do you give a general description of the previous term? So I'll use A as an example. The way to say the previous term is to give a subscript of. Anybody want to go for it? How would I say a general thing that would take care of every previous term? Anybody? Kirsten? Nope. Ileana? N minus 1 will always get you a previous term. For example, if we're talking about the sixth term, that would be A sub 6, right? N is 6. What would be the previous term? 6 minus 1, A sub 5, right? Gets you the previous one. So N minus 1 will always get you the previous term. Okay, so here's our recursive formula. A sub N, any given term, is going to be the previous term plus, think about an arithmetic sequence. What did we do up here? When I asked you what was A sub 4, how did you figure out what a sub 4 was? So therefore the formula is going to be a sub n equals a sub n minus 1 plus the common difference, which is d, right? Isn't that how you get the next term? You add d to the previous one, and that's all we're doing. Look, don't make that mysterious. This is simply add d to the previous term. You'll get the next one. So all of that, junk, all of that notation is just simply add d to the previous term. We can do that. You can do that. All right, A. Write the recursive formula for 3, 7, 11, 15, dots. All right, this is pretty easy. Here's how it's going to start. A sub n equals a sub n minus 1. Now all I've got to do is finish it. And therefore I will finish it with plus what? Plus 4. And I am done, right? That's it. All I had to do was supply the common difference. Therefore, if I ask you for a sub 5, you're going to say it's a sub 4 plus 4, or 15 plus 4, 19. All right, so B here, write the recursive formula. All right, so you got to think a little bit here. So how am I going to start with B? Somebody tell me what to write to start out with B. Looking for somebody that's non-participatory. Come on, participate, peoples. I see the same hands. Want me to call on you? Gonna have to call. Gonna have to call. Who will I call on? Alexandra, what do you think? How are we gonna start this one? Hold on, don't write anything yet. I want to get your opinion. Everybody like the way we started? Agreed? How many agree? Right? Definitely. How many? Any disagreement? We have some disagreement. Mr. Shockey, what do you want? The rest of you dissenters, is that what you wanted? All right. So, now you have to either be stubborn or convert. You gotta hang in there with your convictions if it's a conviction, or convert. And maybe the Shockies will convert to the, who did I ask first? The Winterodites. Or the Winterodites will convert to the Shockies. All right. Any conversions out here? Any conversions? Oh, a lot of hands. I think we're converting to the Shockies. And rightly so, right? Because we got B there, so we're going to go B sub n. We're making it specific to the sequence. And can we figure out D? D is what, a negative 4.2 again? All right, and that was that sequence up above. All right, so in C, they gave us the recursive formula, right? And now we want to find d sub 20. If we're told d sub 24 equals 19, what's d sub 25? Piece of cake, right? It's like elementary, my dear Watson. So d sub 25 is going to be d sub 24, right? Negative 19. Minus 5, I'm just subbing in, right? So all I'm doing is subbing into the formula because I do know the previous term. And we all know that that's negative 24, right? Look, what if they didn't say d sub 24? Well, now you really can't even do the problem because you don't know what the first term is. You might say, well, the first term's 1. Well, how do you know? What if the sequence started at 7? What if the sequence started at negative 13? You don't know. So you really couldn't do it without some info. They would have told you something else. Okay. Recursive leads us to... Anybody remember the name of the other one? Abbe. Explicit, which is the more valuable one, in my opinion. The explicits. Do you guys have that as a vocab word? To be explicit is to be definite, is to be declarative, is to be definitive. All right, the explicit formula, general term formula, allows you to calculate any term. Any term. So the explicit formula can give you any term. Obviously a lot more valuable. Recursive, you got to know the previous term. Well, what if you don't know the previous term? Can't do it. What if you can't find the previous term? Can't do it. Explicit formula, you can find any term. So here's how it goes. A sub n equals A sub 1, the first term, plus the quantity n minus 1 times d. So there is one condition. You do have to know the first term. But sometimes the explicit formula has the first term already taken into consideration. And I'll show you that in a minute. It's already there provided. And you'll see that there's really two ways to show the explicit formula. Okay, so simplify this for a specific sequence. And then you don't even have to worry about A sub 1, and I'll show you that in a minute. Okay, here's the first example. A sub n equals 3n minus 2. Okay, this is already the specific sequence explicit formula. A sub 1 is already taken into account, and it's simplified into this. So the 10th term would be A sub 10. Does that make sense? Right? Remember, the subscript tells you the term. And so it's going to equal 3. And where the n is, I got to sub in something. So what do I put in for the n? I put in, what is n? Ooh, a lot of hesitation there. So a lot of people don't know what n is. Right? So what is n? N is 10. N is whatever the term is you're looking for, that term. So finishing this off, 30 minus 2 is a 28, right? 30 minus 2, so the 10th term, I should keep it A sub 10, is 28. 10th term is 28. If I asked you the 5,000th term, you could figure it out, right? It's 1,498, right? Wait, did I say the 5,000? It's 15,498. 14,498. All right, we'll get this sooner or later. Whatever. All right, so next one. Go ahead and do the 35th term of B. 35th term. I'm going to pause the video. Come on. 2 times 35 is 70. Times 2 is 140. So what do you got? You got 7 positives and 140 negatives. Leaves you a negative 133, right? Do you concur? All right. Negative 4 times 35. Negative 2 times 35 is negative 70, and then double it, negative 140. 7 positives, 140 negatives leaves you 133 negatives. All right, hopefully you're okay with that. Okay, so here we've got to write the explicit formula. So we're going to start with the explicit formula. Yeah. So if you look up above, it's A sub n equals A sub 1, right? Plus n minus 1 times d. Just straight out explicit formula. Now let's get specific. Can we put a number in for a sub 1? Yes or no? Do we know a sub 1? We do. It's the 13, right, is a sub 1. N we don't know. That's the variable. Do we have a value for D? D is 6. All right, so we put a 6 in for D. Can we simplify this? We can, though I didn't leave you a whole lot of room to do it. We can. So you got a sub n equals 13. Now look, if you don't like distributing from the back, you can use the commutative property and put the 6 in front of the parentheses, right? Or you can just do n times 6 is 6n, and negative 1 times 6 is negative 6. But again, if you don't like distributing the other way, or you can do 6 times n and 6 times negative 1, or you can just put the 6 in front 3 ways to skin this cat. And you know I like skinning cats. All right, a sub n, only figuratively though. A sub n equals, so it's combined like terms, 6n plus 7. And see, now we have that specific formula to this sequence, and therefore we can figure out any term of this sequence. So what did I do? I wrote the general explicit formula, and I subbed in the first term. I subbed in D, and I simplified what I had. So if I do ask you for the explicit formula for a given sequence, make sure you finish at a sub n equals 6n plus 7. Don't stop here. Do your math and distributing, right? Simplify it. Hopefully that makes sense. Okay. Oh, brother. I'm way ahead of myself. I should have pulled my screen down. All right, we should have found a sub 1 and D and then did what we did. All right, I'm way ahead. Sorry about that. I should have looked. That's what happens when you make up notes and then you have to try to follow them. So there was all the room to do that. See, I was thinking right the first time. My shade led me astray. So, all right. So, but again, all you got to do is find a sub 1, find D, and then sub it in and simplify, and that's what we did up above, and there we go. All right, so number 4 is easy. Go ahead and find a sub 11. What is a sub 11? Give me a sub 11. So what is that? Negative 33 plus 5, negative 38, and you're done, right? Negative 3 times 11 is a negative 33, minus 5 is negative 38. Voila, you are there. Good to go. Easy, easy, easy. All right, what's the last one? Right. Oh, no. Oh, write the recursive formula. Hey, remember, if you'll just keep in mind previous term, then hopefully you can write the recursive formula. So a sub n equals, remember what the previous term is? A sub n minus 1. And then you'll have to do what? Add D, right? So now we got to make it specific to this thing. And the only thing you can do specific in the recursive is to supply D. And what is D? It is a negative 5, right? And I was using the example from up here, right? So the recursive formula always look like that, and that's as specific as you can get. Okay, so let me do a quick recap. So we talked about arithmetic sequences. What are they? There's always a common difference between every term. Next chapter, we'll talk about a geometric sequence. And if you remember, those don't have a common difference. They have a common ratio. Common ratio. So arithmetic, common difference. Infinite and finite. Recursive formulas. Explicit formula, way more valuable. And voila. All right, homework is there.